CCNA 4 Connecting Networks, Chapter number 9 Troubleshooting the Network. In this chapter, we will discuss troubleshooting with a systematic approach, how to troubleshoot a network, and we will end up a chapter with a summary and main review points. Troubleshooting with a systematic approach. The main objective of these lessons are how network documentation is developed and used to troubleshoot different network issues, what is the general troubleshooting process, and then we can compare the troubleshooting method that uses a systematic layered approach. We will describe the troubleshooting tools which are used to gather and analyze symptoms of network problems. We will determine the symptoms and causes of network problems using a layered model, and we will troubleshoot a network using a layered model. Network documentation. Network documentation is a complete set of accurate and current network documentation. The network documentation includes configuration files, which includes the network configuration files and end system configuration files, the physical and logical topology diagrams, and a baseline performance level. What is included in a network topology diagram? We have a physical topology and logical topology. In a physical topology, that includes the device type, its model and manufacturer, the operating system version used in the device, the type of cable used and its identifier, specification of the cable as well as the connector and the type of the connector, and then most importantly the cabling endpoints. In a logical topology, it includes device identifiers, IP addresses and prefix lengths, interface identifiers, which includes the connection type, DLCI for virtual circuits, site-to-site virtual private networks, routing protocols, static routes, data link protocols, which includes the WAN technologies which is used. Establishing a network baselines. A few questions that a network baseline answers. Can the network meet the identified policies? What part of the network is most heavily used? What part of the network is least used? What alerts thresholds should be set for devices that need to be monitored? Where are the most errors occurring? And how does the network perform during a normal or average day? The network baseline determines the personality of a network under normal conditions. If we would like to establish a network baseline, we have to go through the certain steps. Step number 1, determine what types of data to collect. Step number 2, then we need to identify the devices and ports of interest. And in step number 3, we will determine the baseline duration. Measuring data. We are using commands that are useful to the network documentation process, such as ping, telnet, show IP interface brief, show IPv6 interface brief, show IP route, show IPv6 route, and show CDP neighbor detail. For troubleshooting, we have a general troubleshooting procedure. As you can see in this flowchart, stage number 1 is to gather the symptoms, and stage number 2 we have to isolate the problem. Stage number 3 we have to implement the corrective action, and there we have to make a decision. If the problem is fixed, yes, we need to document the solution and save the changes. And if the problem is not fixed, or if it creates another problem, undo the corrective action and start over again from stage number 1. Gathering symptoms. Below we have some commands for gathering the symptoms such as ping. Two arguments we can pass with the ping command such as host and IP address. Trace route. This identifies the path a packet takes through the networks. The destination variable is the host name or IP address of a target system. Telnet, which connects to an IP address using the Telnet application. Show IP interface brief and show IPv6 interface brief. This command displays a summary of the status of all interfaces on a device. Show IP route and show IPv6 route. These commands display contents of the currently running configurations file. Show running configuration. This command displays a list of options for enabling or disabling the debugging events on a device. No debug command. This command displays a list of options for enabling or disabling debugging events on a device. And show protocol. This command displays the configured protocol and shows the global and interface specific status of any configured layer 3 protocol. In a troubleshooting process, we have some questions for end users. We have some basic guidelines and example guideline questions. For example, in a guideline, as an administrator, need to ask the questions that are pertinent to the problem. Like, as an example, what does not work? Use each question as means to either eliminate or discover the possible problems. Speak at a technical level that user can understand. Ask the user when the problem was first noticed. Did anything unusual happen since the last time it worked? Ask the user to recreate the problem if possible. Determine the sequence of events that took place before the problem happened. Isolating the issue using layered model. Using the layered models for troubleshooting, here we are using the Open Systems Interconnection Reference Model, which includes the 7 layers: application layer, presentation layer, unsession layer, transport layer, network layer, data link layer, and physical layer. When it comes to the end systems, we are using the OSI reference model to the 3 layers, namely application, presentation, and session. One is the issue related to the transport layer, which include the devices such as router, multi-layer switch, and firewall. These are about transport and network layer issues. When the issue related to a data link layer, we will talk about the standard switch, and when it comes to the physical layer, hub. Troubleshooting methods. Using the layered models, there are 3 primary methods for troubleshooting the networks. The first one is called the bottom-up method. Second one is a top-down approach, and the third one is divide and conquer. In addition to the systematic layered approach to troubleshooting, there are also less structured troubleshooting approaches. One troubleshooting approach is based on an educated guess by the network administrator based on the symptoms of the problem. Another approach, which involves comparing a working and non-working situation and spotting the significant differences. Swapping the problematic device with a non-working device is a quick way to troubleshoot. These are the guidelines for selecting the troubleshooting method. The first guideline is determine the scope of the problem. If it is a very limited approach, a very limited problem, we can use a top-down method. But if the problem is complex, we can use a bottom-up method. Then we have to analyze the symptoms and then apply the previous experience. If it is a new problem, we can use the bottom-up method. If it is experienced before, we can use the divide and conquer method. Network troubleshooting. Different softwares are used for troubleshooting the network. These are commonly known as network troubleshooting tools, which are not limited to NMS tools, knowledge bases, baselining tools, host-based protocol analyzers, and Cisco IOS EPC. Similarly, we have some hardware-related troubleshooting tools, and these hardware troubleshooting tools are such as network analysis module, digital multimeters, cable testers, cable analyzers, and portable network analyzers. Using a syslog server for troubleshooting, it depends on the severity level, which is numbered from 0, a highest level, to number 7, which is the lowest level. And here all the troubleshooting categories are divided into levels and with the keywords. For example, level 0, the keyword uses emergencies and the description is system is unusable. Level 1, alerts, immediate action is needed. Level 2 is critical conditions exist. Level 3, error conditions exist. Level 4, warning conditions exist. Level 5, notification, normal but significant condition. Level 6 is informational, description is informational message only. And level 7 is debugging, which are debugging the messages. When it comes to the physical layer troubleshooting, at the physical layer we have different symptoms such as lower performance than baseline, loss of connectivity, network bottlenecks or congestion, high utilization of CPU, console error messages. These symptoms on a physical layer are causes due to power related, hardware faults, cable faults, attenuation, noise, interface configuration errors. Symptoms and causes of a network troubleshooting at a data link layer. Different symptoms exist at a data link layer, such as no functionality or connectivity at a network layer or above, network operating below the baseline performance levels, and excessive broadcasts, console messages. These symptoms could cause due to encapsulation errors, address mapping errors, framing errors, and STP failure or loops. Network layer troubleshooting. At this layer, the common symptoms of the network troubleshooting is a network failure, suboptimal performance, and these symptoms could cause because of the general network issues, connectivity issues, neighbor issues, topology database, and routing table. Similarly, at the transport layer troubleshooting includes the access control list, and some of the common access control list misconfigurations are selection of traffic flow, the order of the ACL entries, implicit deny all, address and IPv4 wildcard masks, selection of transport layer protocol, source and destination ports, use of the established keyword, and uncommon protocols. Issues related at the transport layer such as NAT for IPv version 4. The common interoperability areas are BOOTP and Dynamic Host Configuration Protocol DHCP, domain name systems such as DNS and WINS, Simple Network Management Protocol or SNMP, tunneling and encryption protocols. Issues which is related to the application layer troubleshooting. This includes various protocols such as HTTP, Telnet, FTP, TFTP, SMTP, POP, IMAP, SNMP, NTP, DNS, and NNTP, with different services such as NFS, XDR, and remote procedure call. And similarly to the subsequent layers, the issues related to the transport layer, we can use the OSI reference model and we can map it with the TCP IP reference model, and then layer to layer we can compare at which layer the issue exists. Either is it based off application, is it based on protocol, or is it based on the network condition. The components of troubleshooting end-to-end connectivity. When there is no end-to-end connectivity and the administrator chooses to troubleshoot with a bottom-up approach, these are some of the common steps an administrator must need to be aware of. Step number 1, he or she can check the physical connectivity at the point where network communication stops, including cables and hardware. The problem might be with a faulty cable or interface, or it does involve misconfigured or faulty hardware. The second step is to check for duplex mismatches, and in the third step, the network administrator can check the data link and network layer addressing on the local network. This includes IPv4 address resolution protocol tables, IPv6 neighbor tables, MAC address tables, and VLAN assignments. Then he has to verify that the default gateway is correct. Also, he need to make sure that devices are determining the correct path from the source to the destination, manipulate the routing information if necessary, and then verify that the transport layer is functioning properly. Telnet can also be used to test transport layer connections from the command line. In step number 7, he has to verify that there are no ACL blocking traffic. And in step number 8, he need to make sure that DNS settings are correct and there should be an accessible DNS server. In this PowerPoint presentation, it shows the end-to-end connectivity problem initiates the troubleshooting. For example, PC1 is unable to communicate to server 1 on a different domain, so administrator can use the ping and trace route tools. Step 1, verify the physical layer. So on router 1, show interface gigabit giga ethernet 0x0 command is issued, which shows the different options like the line protocol is up, giga ethernet is up, and then input Q shows the size, maximum drops and flushes, and total output drops. What is the Q at the output, what are the input errors, and what are the output errors. In step number 2, for troubleshooting the IP connectivity, some have to check for duplex mismatches. In order to check the duplex mismatches, a few guidelines need to be considered, such as point-to-point Ethernet links should always run in full duplex mode. Half duplex is not common anymore and mostly encountered if hubs are used. Auto negotiation of speed and duplex is recommended. If auto negotiation does not work, manually set the speed and duplex on both ends, and half duplex on both ends perform better than a duplex mismatch. Troubleshooting IPv connectivity, step number 3, how to verify layer 2 and layer 3 addressing on a local network. If IP version 4 is used, we can use ARP command at the computer and by issuing show MAC address table command on the router. So you can see here on router 1 we issue the command show IP route, and then on a local PC we use the command route print. Similarly, if IPv6 is configured, we can use netsh interface IPv6 show neighbor command on PC and show IPv6 neighbors, which will verify the IPv6 default gateway. Verifying the default gateway. Verify the IPv4 default gateway on a router by simply issuing the command show IP route, and on a computer we have to use a command route print, which will give the network, the destination, the net mask, and a gateway. Similarly, if we have configured IPv6, so the command on the personal computer is ipconfig, which shows the information related to IPv6 and default gateway information in a hexadecimal format. Step number 5 is verifying the correct path. It's like a flow chart. Starting right from destination IP address, match in the routing table. If it is yes, match with more than one entry. If it is yes, then all the entries have the same prefix lengths. Forward the packet using the longest matching prefix length, or forward the packet using the load balancing. If the route is mismatch, no, then choose the default route. If it is no, then it will discard it the packet. If the default route matches, then it will forward the packet to the destination. How to verify the transport layer? We can use a successful telnet connection over IPv4 by giving the command telnet and then destination IP address. Step number 7, verifying the access control list on a router by using the troubleshooting method. This basically prevents the spoofing attack, denying all packets with the source address and from entering to the serial. Depends how the router interface has been configured and which security measures has been taken and which type of traffic is allowed or denied subsequently. In order to verify the DNS entries on a given router, we have to issue the command IP host IPv4-server and then the destination address, and then we can issue the ping IPv4 server. If everything is okay, then a successful message is coming that the success rate is 100%. Similarly, if we have configured IPv6, you can issue the command IPv6 host space IPv6-server and then address in a hexadecimal format, and then we can ping the IPv server. If the connection is successful, we will get a success message that the success rate is 100%. And finally, the summary of the chapter number 9. We have discussed the guidelines for selecting a troubleshooting method such as top-down method, bottom-up method, and divide and conquer method. It depends which circumstances the administrator is using, his or her knowledge, experience, size of the network, and different issues related to various layers. He has to specify the scope of the problem, analyze the symptoms, and then apply the previous experiences. I hope you like chapter number 9 and thank you for watching.